Okay. All right, so here's the idea with reflections, okay? Um, if you have some kind of an object, let's say like this triangle here. Looks like a triangle to me. So if you got this triangle and you want to reflect it, what you need to have is a line of reflection, okay? Kind of like if you were staring in a mirror and you could look at both yourself and your reflection in the mirror at the same time, kind of from the side. So let's say like this is our line of reflection. So to reflect over that line of reflection, then all we need to do is to take every point that's in the figure, and rather than translating it, you figure out how far that point is from the line of reflection, and then go that same distance the other side of it. Okay? So let's say we've got the triangle. This is A, B, C. So if we start with like the point C, how far is point C from that line of reflection? 1 unit over, right? So we'd go to the other side, 1 unit. So there's C prime. Okay, so A, how far is that? 1, 2, 3, 4. Okay, so 1, 2, 3, 4. There's A prime. And B prime, how far is that from the line? 1, 2. So other side of it, 1, 2.
Oh my goodness. That was so hard. I feel
Okay, so one thing to take note of, unlike a translation, the orientation of the image and the pre-image are different this time, right? With a translation, everything was in this, like if you had something going on in like the upper left-hand corner of the pre-image, that same thing was happening in the upper left-hand corner of the image. Everything kind of stayed relative to itself in the same place. In a reflection, that's not the case, right? Everything flips around, so things are looking a little backwards by the time you're done. Okay? However, is a reflection a rigid motion? Is the image and pre-image, are they congruent to each other? Yes, they are. Remember, congruent simply means same shape and size. So is the first triangle and the second triangle the same shape and size? Yeah. So it is a rigid motion. It's just been turned around. Okay? So I'm going to jot that down. Okay, it is a rigid motion because triangle ABC is congruent to triangle A prime, B prime, C prime. Okay, everything still matches up, it's just flipped around there. Okay, so like I said before, with translations, we're going to, just like with translations, we're going to be looking at reflections in a coordinate plane. Okay, so we're going to look at two types, well actually three different types of reflections. Over the x-axis, or a horizontal line, over the y-axis, or vertical line, and then we're going to look at diagonal lines too. Okay, so we're going to start by just looking at what if we do some reflections over the x-axis. So we'll draw just a small coordinate plane here going out to 4 in every direction. Have a few points here. C is at 2, negative 2. And maybe we've got D over here at negative 1, 0. Okay, so let's say I want to take each one of those points, reflect them over the x-axis. Okay, so you can probably just eyeball it and do it. Okay, but I want you to take notice of what the new coordinates are compared to what the old coordinates were. So if B was at 3, 2, and I want to go over the x-axis, okay, so B prime is going to be down here, right? Kind of in the way of C. What are the coordinates of B prime? 3, negative 2. Okay, what if I did the same thing with C? I'd have to come up, right, to here. So there's my C prime. What are the coordinates of C prime? 2, 2. Okay, and so A prime would be 1, 2, 3 down here. What do you notice about the coordinates of A prime? What should those be? Negative 2, negative 3. And what about D? It doesn't move, right? Still negative 1, 0. Okay, so can anybody tell me what's the pattern that's going on with all the coordinates of these points when we reflect it over the x-axis? Yeah.
The y value changes.
Right, the sign on the y value changes to positive, from positive to negative, or vice versa. What about the x? Yeah, stays the same. Okay, so going over the x-axis, no matter what, you've got that pattern happening. Okay, so let's jot that down. The y value changes sign, and the x value stays the same. So that's a reflection over the x-axis. So what do you suppose happens if you reflect over the y-axis instead? Jason? There you go. Okay, if you go over that y-axis, the y value doesn't change, but the x value will change its sign. Okay, so let's write that down over here. All right, so if we're looking at a reflection over the y-axis, the y value stays the same. And the x value changes sign. So the way that I always kind of just memorize these little rules here, I mean, you can draw it and look at it, and it's pretty simple to do. But if you don't want to have to draw it every time, you could just remember, okay, over the x-axis, x stays the same. Over the y-axis, y stays the same. It's the other one that changes. Okay? So let's try a few of these. I'm just going to give you some points, tell you an axis that it's going to be reflected over, and see if you can just quickly give me the answer without having to look at it or draw it or anything like that. Okay? So for each of these, you're going to find the coordinates of the image. Okay, so negative 5, 7 over the x-axis. About 2, negative 1 over the y-axis. Zero 8 over the y-axis. And 5 5 over the x. Alright, take a couple minutes. See if you can do each one of these in your head without looking at a graph. Maybe you're drawing the graph in your head. I don't know. Some people can do that too. But whatever you want to do, see if you can do it in your head. All right, do you guys need more time, or are we okay? It's okay to say yes. We're good? Eh? Okay. All right, so like I said, the trick I remember in my head is whatever the axis is, that one stays the same. So, negative 5, 7 over the x-axis, what should it be?
Negative 5, negative 7.
There you go, negative 5, negative 7. Good. Okay. 2, negative 1 over the y-axis. Yes, Mr. Franken? Negative 2, negative 1. That's over the y-axis, so the y stays the same. The x changes. 0, 8. Somebody else. Yeah, Tara. 0, 8. The y stays the same. The 0 changes sign, but it's 0, so it's still 0. And then 5, 5. Yeah. 5, negative 5. Good. Correct. Yes. So